Alright, and what we can see here is a CoreXY kinematic system. It uses steel rods for all of the motion in the XY plane. And in the Z plane, it looks like we've got some steel rods in the back. So this is going to move the bed up and down. This was also in the box. And then this hat thing, I assume that goes on the top like this. And that'll let us print at higher temperatures. We've got a power cord, tools, a big old scraper here, nice pair of tweezers, and looking up close, this is some kind of little breakout board. I bet we'll figure out what this is used for later. We've got a nice little mini spool of filament. So now let's go through the instruction manual and put this thing together. Alright, so now we've got our nice little door thing going on here. Time to attach this extruder. Cable management seems pretty good. These belts seem like they might be a little loose. I can get the belts to skip if I move things fast enough here. So now I've got my filament spool holder down here, and this is going to go up through here, into this tube, through this little guide, and into this Boron tube, and feed it up into the extruder up top. According to the instructions, I need to change the voltage. I think you can actually see it through the door here. It's already set to 115 volts. I think that concludes the assembly. Yeah, I guess we're ready to turn this on, so here goes nothing. Before we get started, I probably need to do some bed leveling. Looks like there's no ABL sensor. This tool head seems a bit floppy. I can twist it back and forth. However, if it's mass balanced, there shouldn't be much of a torque put on it, even when it's accelerating quickly. And it appears that these belts and everything goes right through the center of gravity of this thing. So it doesn't actually have to be that mechanically stiff in order to print accurately, even at high speeds. Let's see if we go into the tool setting, we go to bed leveling. Let's get out our handy piece of paper here and do some bed leveling. Alright, everything seems pretty level. I think I just want to go ahead and print something. So this is a PTFE lined heat break. That means I'll pretty much be sticking with PLA. Alright, looks like the printer is starting up. It's moving around a little bit. So we'll see what the print quality looks like. Now, one thing I really like about this machine is how quiet it is. Just listen to this. All the fans are quiet. The motion system is super quiet. I mean, this thing's just a joy to listen to. I guess that's why they call it the Ghost. It's so quiet. I just looked up the price. It's pretty affordable too, so, you know, we might have another recommendation here on the channel. So our first print job finished up in 2 hours and 23 minutes. It looks like this print turned out pretty good. You can actually see the individual facets of the STL model. The overhang angles are printed quite well. This is over a 45-degree angle. Up at the top here, this didn't print correctly, but I'm not sure what they were thinking. You know, this is kind of printing a circle in midair. But all of these overhanging surfaces from all 4 angles printed really nicely. So that tells me that they've got a really good part cooling solution on there. You can see we've got one 4010 blower fan on the left side. We've got the same setup on the right side. So two 4010 blower fans with some efficient ducts that are pointing the air right to where you're printing. And in the front here we've got a silent axial fan. Normally I like to replace these fans with Noctua fans because the ones they ship with end up being too loud. But this one's nice and quiet, so I don't really see the need to change anything on here. The only thing I might do is, if I really want to get into the electronics of it all, add something to smooth out that PWM pulsing that the motors have. That'll quiet it down just a little bit more. But as it is, it's a perfectly serviceable and quiet machine. The filament that I'm going to use today is this Polyterra muted green. If you take a look in this clear window, you can see the filament right there at the end. So you know you've loaded your filament correctly. We're going to print out our Swolebasaur. Oh wow, it started printing. I was working on something else and it's just going, but it's so quiet I could barely hear it. Everything looks pretty good there. This should be a perfect first layer. By the way, I'm doing a podcast every other week now, and you should check it out on Spotify or wherever you get your podcasts. It's called The Perfect First Layer. I'm co-hosting it with 2 other people. We've got Guy from Guy's Woodshop, and then we've got me and JJ Shankles. So if you've got a long commute, you should go ahead and check that out because it's pretty entertaining, and you learn a lot about 3D printing. So I'm going to go ahead and switch this to time-lapse mode just so that we can turbo through this print. It's almost 10 hours long, so I don't think you want to watch the full one-time speed copy of this. So let's crank up the speed and just watch this thing take form before your very eyes. Alright, so our first print just finished up. I think it looks pretty good, but let's take a closer look. If I turn my lights off, it's got a little light bar up at the top. You can see your printed part. I should probably be a little careful removing this off the bed. What's up, baby?
You have stuff in your teeth.
Thank you. Thank you for reminding me. I won't be on camera, but I'll get it out of my teeth before I start filming myself.
Okay, bye.
Okay, bye. Anyways, that was my manager. She's very particular about my appearance on camera. She makes sure that I get my haircuts done every week. Let's get this off the build tray. That's sticking pretty good. Our support material looks like it came out pretty nicely. And let's just try and remove it now. I mean, that's about as easy as it gets. And would you look at that? This all turned out really nice. That support material didn't leave too much of a mark. Let's do some close-ups of this guy so we can see the print quality up close. I mean, these details look pretty fantastic. This is with the optimal print profile using Prusa Slicer, and I'm just treating this thing as if it's an Ender 3S1, so I'm basically just using the same settings that I use on my Ender 3S1s. This looks really dang good. Now, why would you want to print something like this? I honestly have no idea. This seems to be a popular model for some reason. I guess it's like some kind of three-dimensional version of a meme. Here's some close-ups just so you can see those layer lines. I might want to do a little flame polishing down here where the support material was, but really it's not that bad, and when you're viewing this from an upward angle or even horizontally, you don't really notice that stuff. You have to be looking at it from underneath, which most people aren't going to do. Alright, so now I can cross this one off my Pokédex. I've got Swolebasaur. So in terms of print quality, this machine is quite good in its stock configuration. I'm going to pop the side panel off and see what kind of electronics board we have inside of here. When you're not sure in a situation like this, the best thing to do is to just force it. Ugh. Ooh, I can slide it out the bottom here. So apparently this machine is Wi-Fi enabled. I wouldn't know because I rarely use the Wi-Fi functionality on the printers that I get. Looks like we've got a fan here that just blows on this motherboard. Okay, so that's the main board. I don't really have much experience with these maker-base main boards. They seem to be pretty well put together. You've got your stepper drivers here. All of your connectors are held in place with a dab of glue. And up here we've got some kind of questionable stuff going on here. If you're going to be using one of these long term, you should probably unscrew these, put some crimped ferrule ends on there, and screw them back on. You can see here they've used the correct type of wire terminal. Let me unscrew one just so that we can verify. Yeah, it looks like they just had some tinned wires that they stuffed into here. And that's something I would do on a weekend project, but not something I would do on a professionally assembled electronic device. It's probably not going to cause any issues, but it's just a matter of doing things the right way, which it seems like a lot of 3D printer manufacturers don't care about. We've got some pluggable screw terminals here, but we'll just leave all that in place. We don't need to mess with any of this. Then if you look a little bit further up here, you've got all the wires leading to that LCD touchscreen. Down here you've got a little Wi-Fi chip. It looks like it's a module, so you can pull that out and replace it if you need to. And we've got USB-A support as well as a little SD card reader. I've heard from another reviewer that they had an issue with their SD card reader, so there are failures, but they're sending them out a replacement board. These type of repairs are somewhat common in 3D printers, and this type of motherboard is very conventional. It's not like a proprietary board like what we've seen with Bambulabs. Down here we've got an additional port for another stepper motor. Overall, I'd consider this to be a pretty good result in terms of serviceability and packaging. Everything fits nicely into this little area, and also being an all-metal construction means that even if you do have a short, it's much less of a fire hazard than some of the machines that Creality is putting out. This CoreXY motion system is very reminiscent to what you have on the Bambulabs printers. I mean, basically all CoreXY systems work pretty much the same way. The Bambulabs printers have carbon rods for the middle piece. This uses a more conventional steel rod design, which I believe will be more durable in the long run, because carbon rods on brass bushings, that's going to wear out eventually, and you'll eventually get some slop there. The thing will just degrade and need to be replaced. These linear bearings running on steel rods should be much more durable, so I foresee this being a machine that needs less service than the Bambulabs printer. I really like what they've done with the packaging here in terms of putting all the stepper motors up here, up in the top area, so they're easy to access. Looks like we've got some injection molded nylon here, and those are being bolted to this top steel frame that's forming the bulk of the support for the motion system. Pretty clever and efficient design. The only thing that you could really fault it for is it's got a single motor driving the Z-axis up and down. A lot of people complain about that and think that you need more than just a single point of movement. The truth is, in my experience, if you've got pretty good bearings, like these ones, they're like massive linear bearings, then it should do a pretty good job of holding the printer in place. I mean, it got through this whole print without having any issues. I guess you could point to the slight layer inconsistencies we're seeing here and blame that on the Z-axis being maybe a little bit less consistent than something with multiple Z lead screws. But you're really splitting hairs there. I'm pretty impressed by how lightweight and simple everything is. I mean, just because you have a CoreXY motion system doesn't mean you have to overcomplicate things. So take a look back here. They've just got these simple injection molded blocks that hold on to all the bearings and rods. Let's open this sucker up and see if we can replace some parts on the hot end. So we just undo 2 screws here. When you don't know what's going on in here, the best thing you can do is just start unscrewing everything until it falls apart. I actually really like this design because having this be see-through lets you see right inside of the extruder and see if anything's going wrong. I think this is something that other 3D printer manufacturers should definitely adopt. Here we can see our filament in between these 2 large drive gears. Here's our stepper motor. I know some of you out there are freaks that like counting the number of teeth on a gear for fun. So here's a close look at that. You can see most of the gears inside of this are plastic, which I don't really see as an issue. Some people are concerned that a gearbox will wear out eventually if it's made out of plastic. Well, I've got news for you. All gearboxes will wear out eventually, whether they're made out of plastic or metal. Sometimes plastic can last longer because it's naturally lubricating. It doesn't require grease. So overall, this is a really nice and simple extruder design. All injection molded plastic by the looks of it. Alright, so we'll set that aside now that we understand exactly how that extruder works, and we'll turn our attention back to the hot end here. These belts are held in without any additional fasteners. I'm going to use my fancy Nipex pliers to release one of these belts. I'm actually going to tension these belts a little bit just because I think they could probably stand to be a little bit tighter. This just seems like kind of loose. Like, is this too loose? So to tighten this up, I'm just going to pull this belt out and then put it back in place with what I feel like is the correct amount of tension. So I'm just going to cut off 2 teeth. Then I'm going to go ahead and just put this back in place with that extra little bit of tension. If I just pull this until the carriage runs up against that sidewall, now I've got something to pull against. So I'm just going to put some tension on it and then get the belt installed. Now someone in the comments let me know if I'm butchering this and I'm over-tensioning the belts, because I know nothing about CoreXY systems, but I just assume that more tension equals more better. And you can kind of tell how taut these belts are by pulling them, just like a guitar string. They'll make a noise that's proportional to the tension. Tension goes up, frequency goes up. We can pluck this one and pluck the bottom one. They sound about the same now. And you can actually get like a guitar tuning app in order to tune your belts. It's kind of a funny way of literally tuning your machine. Alright, with those belts a little bit tighter now, I'm not having any issues with the belts skipping. Oh geez. Before, when I was moving this around really quickly, I had the belts skipping over the pulleys on the stepper motor back here. Now the nice thing about taking this machine apart and modding it is that it's a lot lower stakes than if you have a Bambulabs machine, because those machines are expensive and you'd have to be an idiot to take one of those apart. Oh, wait. Anyways, let's go back to this one. That's another video for another day. Alright, let's take this apart. Should come right out. There's just two small screws, one here and one here, so I'll undo those and see what happens. Oh yeah, there we go. I think we're doing something now. Unscrew these things. Oh! This is awesome because this is all injection molded, and they're using these injection molding inserts for all the fastener connections. This is a nice durable design that's really inexpensive to manufacture. So it seems like Flying Bear is tooling up, and they should be in the 3D printer business for quite some time because they've already invested in developing all of these tools to make these printer parts. So they're going to be cranking out these machines at a low cost. Just because you're mass producing a design doesn't mean you made a good design. Sometimes these companies, they crank out these subpar designs and they just let their customers deal with it, and they keep making them even though they're not the most efficient. In the middle, we have the Hotend heatsink and the actual heater block right here. And we've got a little miniature breakout board up here. It's absolutely tiny. I think they did a great job making this as small as possible. And we've got really tight integration of some fans. On the left and right sides, we have 4010 blower fans. They're just blowing straight down and out through these little air ducts. Very efficient, short path here. They're not blowing at too harsh of an angle. They're doing these induced flow tricks. So frankly, this is an awesome design. This is about as optimized as you can get for something like this. Then we've got this tiny fan in the front. This is a small 3010 fan. It's right behind this fan grate here. And it just blows air over this heatsink when everything's assembled. What I love about this fan is it's super quiet. Nothing bothers me more when they put these massively overpowered fans on the hot end. Like, you're only having to remove 1 or maybe 2 watts of heat. You don't need a gigantic fan to do that. Something small and quiet like this will get the job done. That's something that really bothers me about a lot of Creality designs. Is they put these massively overpowered fans on there that are just screaming as soon as you turn the machine on and start printing. This is a pleasantly quiet experience, and I really appreciate it. Okay, let's take a look at this breakout board. Right here we've got all of the connections for the fans. 1, 2, 3 fan connectors there. And then we've got all the connections for the hot end. So we've got the heater wires and the thermistor wires all on this nice little terminal block. On the back side of this breakout board, you can see there's the connector that we have that basically just plugs in, and then everything on this hot end is powered. One thing that I'm noticing by looking at this is there's not really any room to add automatic bed leveling, so it won't go through this breakout board if you decide to add that later. As I explained earlier, it's not really necessary when you have a solidly built machine that's using a glass bed that's very flat. You saw the first layers I was getting on this machine. They're quite nice, so you don't really need that automatic bed leveling, but it's a nice to have. So with that out of the way, let's take a slightly deeper dive into this hot end. What I'm going to do is actually replace the PTFE lined heat break in here with an all metal version. You can see this is a PTFE lined heat break. This PTFE tube goes all the way down and it touches the nozzle down inside of the heat block. With all the mods that I do on this channel, you might be wondering how I'm able to make this stuff happen so fast. Well, the truth is I've just got an enormous stockpile of various printer parts. Here's my nice collection of all metal hot ends. This looks like our closest match here, but as you can see, it's a little bit too long. I think we've got a match in terms of the diameter. It's just that the actual part that sticks out of the hot end is sticking out too far. The heat break is about 1 millimeter or 2 longer and further into that heater block. The best solution here might be just get a whole different setup. My favorite little hot ends are these CHC hot ends. You can see these things are absolutely tiny, and they do a really good job of heating up quickly and delivering all the power that I need. So here it is all put together. I'm going to use some good old Boron Nitride thermal paste on this. Ah, jeez, this always happens. It's important not to over tighten these CHT nozzles because you can snap them. I've got a special tool. It says it needs 1.5 Newton meters, so I'm going to go ahead and tighten that up. You'll want the overall height of these two devices to be roughly the same. And if we look at them side by side, the new assembly is about 2 to 3 millimeters longer. I'm just going to have this stick down 2 to 3 millimeters further and then I'll make adjustments to the bed so that everything still works out. Alright, so that means the next step is I got to wire this up, so we'll have to do all the electrical connections. Looks like there's 2 screws in the back of the heatsink, so we'll undo those, and that'll let go of this old heat break. And then I'll install this heatsink onto this new setup. I'm going to use some of this Noctua thermal compound, just a tiny bit, we don't need much. I would say like the size of a grain of rice. And then insert it into the heatsink here. I'll twist it around just to spread that evenly. And that should increase our heat transfer a little bit, which is always a good thing. If you have a heatsink, you pretty much always want to transfer heat into it. We're going to have to unscrew the wires from this old heater block and screw these new wires in. And we'll just need to loosen up these 4 screw terminals. Pull all these out. I'm going to put some crimped ferrule ends on these wires and insert them into these little holes. To do this, I've got my crimped ferrules here. As you can see, I dropped it on the floor with the lid open, so this is kind of a disaster now. And these cables don't have to be very long. I'm just going to go ahead and cut them like this, and then strip the wires back so I can put the crimped ferrule ends and then install them into these little terminal blocks. In order to do this correctly, you're going to want to use those crimped ferrule ends and one of these crimping tools. So that's what I did here. I've attached those 4 things, and I also trimmed the ends a little bit so that they're not too long to stick into these terminal blocks. Alright, now to put this together, I believe 15, or these ones on the bottom, are for the heater cartridge, and then 14, or these 2 on the top, are for the thermistor. We'll just tighten up these screws, and then we'll put this back in over here. Everything's looking great. Now I'll just put the silicone sock on there, and we've got a nice little hot end set up. I think this piece on the back is just there to hold in all of the wires. Now comes time to put this thing back together, so let's go ahead and do it. First I'm going to attach the 2 heatsink screws. That helps make sure everything's aligned. And we'll do these 4 screws. Alright, so that's all good. I've got these nice Knipex pliers. I think if you do a lot of work with electronics, some of these things are just worth it to have. I know not everyone's going to have tools this nice, but use them if you got them. Before we bolt this down, I'm going to go ahead and cut a new length of PTFE tube. All this PTFE tube is doing is guiding it from the outlet of the extruder down into the heatsink. Now we've got a nice little bit of PTFE sticking out the top here. We're just going to have to put these 2 screws in the sides to attach the extruder back to the machine, and then do another bed leveling to account for the change in nozzle height, and then we'll be ready to print. And of course I'm going to finish this off by actually running a long print and make sure I didn't just film a 30-minute guide on how to ruin your 3D printer. It's always an exciting time to fire up your 3D printer after spending a little while putting some mods in, because you never know what's going to happen. Wait, actually, there's one last thing I want to address here, and that's these screw terminals that are being used in the base of the machine. We'll fix up this wiring and make it a little bit more professional before we fire this thing back up again. So what you're going to want to do here is unscrew these 4 screw terminals. I'm going to take all this glue out. I'm not sure what that glue is supposed to do. So then I'm going to take these one at a time and crimp some proper Spade connectors onto them. So you'll put these on, and then using a crimping tool, something like this, you're going to want to line this up. In this case I'm going to use the red dot hole because that's for these red colored crimpers, and we'll just crimp it. This will be inserted into this connector just like so, and then when you screw these down you don't have to worry about them coming loose or anything. This is the professional way to do it, and in my opinion all 3D printers should be professionally assembled to a high standard, just because these are high-powered electronics that could burn down your house. Then you're going to want to repeat the process for all of these other wires, so just one at a time, pull them out, crimp them, and put them back together. The Spade connectors that I'm using are out of this kit, and you can tell that this is the right kit because it says you can use it on 3D printers. While I'm in here, I'd like to point out one other thing. You got to give credit where credit's due. On the heated bed, they're actually using high strand count silicone wire, which is what you need to use on a repeatedly flexing cable like what you have on a heated bed. A lot of printers use just regular wire for that, and that'll fray over time and eventually wear out, possibly heat up and cause some serious issues. So I really appreciate how they're using high strand count silicone wire. It's not as important on this machine because it's not a bed slinger. On a bed slinger, that cable's bending back and forth every time you lay a layer down. On this, it's just moving very so slightly up and down as you're changing Z height, but every time you run a print, it's flexing back and forth. And anytime you have a moving joint, you want to have flexible wire in there so you don't have issues with it breaking down over time. Okay, anyways, I'm going to crimp these last two connectors on here, and that should conclude my mods for today. Ta-da! Alright, and when you finish this all up, you should be left with a nice, professionally wired little bank of Spade connectors here. Alright, and if I didn't horribly mess anything up, we should be good to turn this machine on and start up a print. The only thing I haven't really covered mechanically about this build is this little junction block here where we've got a couple bearings and the linear bearings and rods being pressed into this thing. This is super minimal. I really like this, and you can see how it's constructed from the side here. We've just got a little metal plate that holds these bearings in place. The one thing that I'm really going to have to do here before I start, I have to do this bed releveling because everything kind of got shifted down, or should be shifted down, to account for this new nozzle. Go into Tool, Leveling, and we'll go to Bed Leveling 0.1. It's pinching the paper even with this all the way tightened down. So what I'm going to do is dial in some Z offset. Okay, Z offset. Maybe we need to go positive. Yeah, that makes more sense. Uh-oh, we've got some screen artifacting going on. Hopefully that's fine. Let's go back. Yeah, that's fine. Not a big deal. You know how these bed leveling things work. It just takes a little bit of time. But from what I've heard, this machine does a pretty good job of holding zero once you find it. This should be a much faster print since we've got that larger CHT nozzle. We should be able to push around 30 cubic millimeters per second, no problem. We've also got an option to turn on and off this 50-15 fan that's in the back of the printer. That'll just help you evacuate air if you're trying to keep your print chamber a little bit cooler. For me, I don't think I'm going to need that. It's nice to have the option though. And if you're feeling really cheeky, you could have it power something else. Like if you wanted some additional lights in here, you could wire those up to that fan, and then you'd have a built-in interface to be able to turn those fans on and off here. That chamber fan in the back is really nice and quiet, so it seems like they paid attention to the noise levels when it comes to the fan selection for this machine. Alright, I just adjusted it so our first layer should be pretty much perfect, and I already told you how important it is to have a perfect first layer, especially having that perfect first layer podcasts in your subscription feed, wherever you get your podcasts. I kind of want to put an acrylic sheet here. That way we get a nice second view inside of the printer so we can see what's going on. And also we'll get this nice view of the main board and see what blinky lights are doing. I don't know, that seems kind of entertaining to me. So here goes nothing. Enjoy the time lapse. Alright, so there you go. We've got two really nicely printed models here. Overall, I really do like the print quality that you get with the 0.4mm nozzle, but with the 0.6mm nozzle, you can more than double your print speeds when you turn up to an aggressive profile. It looks like we've got a few under extrusion artifacts here, so I might have to make some adjustments to this machine. I would probably leave this as a 0.4mm nozzle. I just wanted to see what this thing could do if I turned up the print speed significantly. This one just looks great, really awesome print. This one, not so much. So now that we've taken a look at all of the major subsystems of the Flying Bear and gotten familiar with the internal circuitry, the motion system, and its modability, it's time to share my final thoughts on the Flying Bear Ghost 6. What this thing does extremely well is provide you a good option for a CoreXY printer on a budget. Due to the lightweight printhead and the inherent advantages of a CoreXY system, you're going to be able to push faster print speeds than you can get on an Ender 3 or similar bed slinger. CoreXY isn't all about speed. There's some other real advantages to having a CoreXY system, like the efficient packaging. You're getting a pretty large print volume into a small area. The other inherent advantage is it lends itself to being enclosed easily. You can see this already comes with 5 sides of a cube all closed up. You've got this hat which can go on the top. Say you have this thing out in your garage and it goes below freezing outside. Well, having this nice enclosed printer means that the print volume will stay relatively warm and you won't have the same kind of issues that you would have with an unenclosed printer in a cold space. It also blocks any drafts of air that could interrupt your print, and it keeps hands and feet and toes and pets out of this area. So if you have kids or pets and you're worried about them getting in there and touching the hot end and possibly getting burnt or ruining your prints, you don't have to worry about that as much with this printer. This CoreXY system looks like it'll be pretty easy to maintain, and it's just constructed out of really simple hardware and lightweight, inexpensive components. So maintenance on this thing should be a breeze. If you look at the Bambulabs printer, which I'm going to do in a future episode, I'm kind of in the middle of taking that machine apart. It's basically unserviceable. So as soon as that thing's done with its service life, you throw it in the trash and you get a new one. Whereas a printer like this or your old Ender 3s, you can infinitely replace the parts on it and keep it running pretty much as long as you want to. This tool head is pretty modular. We took the whole thing apart and took a look at it, and basically it's as moddable as an Ender 3. It's really easy to just pull things out, put new things in. So I see this thing as being a good printer for modders. These steel rods that support the print head aren't the thickest and strongest, so you can wobble the print head around a little bit. But in practice, we can see that it's got excellent print quality. So any type of issues that you would think you would have with this being a little wobbly, it turns out it's just fine. It's got amazing print quality, so really nothing to complain about there. I imagine this flexibility could have issues if you're printing at insane print speeds. On the Bambulabs printers, they use carbon fiber rods along the top here, which, I mean, one of the advantages of carbon fiber is that it's extremely light, but also you can make large, thin-walled tubes out of it that are extremely stiff compared to a similarly sized and spec'd steel rod. So that's one of the secrets of the Bambulabs machine that allows it to print so fast. But this has a huge advantage in terms of serviceability because you're just using common steel parts that you can remove and replace yourself at home. Versus on the Bambulabs printer, you basically have to send it back to the factory, where I assume they throw it in a giant grinder and just send you out a new machine whenever you have issues. The print head and extruder on this thing are quite nice. It's very efficiently built. There's not a whole lot of waste on there. If you look at most of the designs by Creality or other 3D printer manufacturers, you'll see lots of large, heavy parts that could go on a diet a little bit. But on this machine, everything's really efficiently put together and made out of injection molded plastic. So despite this thing being very inexpensive to build, I think it has pretty good build quality. I really like this extruder so far. We'll see how reliable it is in the long run. But this little plastic viewing window in the front is brilliant. You can really see what's going on when you're feeding filament into this thing. Or if you have any nozzle clogs or jams, you'll be able to look right in there into the critical area of the extruder and determine what's going on there. On other extruders, you have to take the whole thing apart just to take a look inside, so that could be pretty frustrating. But on this machine, you have no such issues. Or if you want to move to a different extruder design, I think you could probably 3D print an adapter piece and put pretty much any extruder you want on the top of this machine. The PTFE lined Hotend that comes stock in this machine is a bit of a disappointment. I'd like to see more machines come with an all-metal Hotend these days. I know it's a little bit more expensive and a little more prone to damage, and it requires the user to be a little more knowledgeable, but overall I think it's a good thing to have. I think they had an opportunity to provide an all-metal Hotend, but also make this noob-friendly. They could have shipped a PTFE lined Hotend inside the machine, and if you wanted to upgrade it, since they're providing a second Hotend already, they might as well put an all-metal heat break on this one, so you can just swap that in there if that's something that you want. I found the part cooling on this machine to be excellent. If we look at our Swolebasaur model, there's some pretty steep overhangs that weren't supported, and they printed out very well. Even past 45 degrees, up to 60 or 70 degrees, everything that was printed ended up looking really nice on here. And when I upped the nozzle diameter to my 0.6mm nozzle and was over extruding to a 0.8 millimeter sized extrusion that I was laying down, this still has pretty decent overhangs. So overall, the part cooling solution on this machine is very good, and I don't foresee any need of having to upgrade that later on. It's pretty much as good as you would practically need for a printer like this. It was pretty quiet compared to a lot of other 3D printers, so in that sense, this machine definitely lives up to the name of Ghost. I mean, this thing's just a joy to listen to. I mean, ghosts are quiet, and this machine is definitely quiet. With the stock 0.4 millimeter nozzle, this print quality is amazing. Like, there's really nothing to complain about here. If you're really picky, you might notice that the layers aren't perfectly stacked. You can see a little bit of inconsistency between each layer where the layers are slightly shifted left or right. But overall, I mean, for an entry-level printer, this is amazing print quality. I'll leave links to the parts kits and the tools that I used to put those Spade connectors on there. Personally, I think it's worth doing on these machines, but most people probably wouldn't notice and wouldn't mind the way that things are wired up in here. But at the same time, I'd like to see more 3D printer manufacturers taking wiring safety more seriously and just at least using the appropriate type of connectors when you're attaching things together inside of the main board. Another thing that I really like about this printer is that the electronics are fully enclosed in a steel enclosure, so worst case something bad happens and you have a little fire inside of here. It's all contained and it's not going to light your whole house on fire. I think Creality could learn a few lessons looking at their Ender 3 S1 Pro and the Ender 2 Pro. They both have their electronics mounted in plastic enclosures. And in my opinion, there's nothing pro about that. This also uses a third-party mainboard. It says a MakerBase MKS Nano 4. I really like how they're using a third-party design for their mainboard because it's not locking you into some proprietary nonsense. If you look at a lot of modern 3D printers, they're moving away from these open source style boards and moving towards more proprietary stuff where they're custom making the boards for their 3D printer. If a few years down the road you feel like you want to overhaul your machine and put some crazy upgrades on it, there's definitely going to be a path forward for you because it's using all standardized connectors and everything in here is pretty easy to take apart and service. So that wraps up my thoughts on the Flying Bear Ghost 6. I think it's a great deal for a printer, so I'm just going to put some links down there if you want to look for this thing and buy it. I got this machine for free, but I don't let that kind of thing bias my opinion. Thanks for watching this episode of Nathan Builds Robots. I've got some great new videos coming up, so if you're not already, subscribe to the channel and check those out. And thanks for watching. I'll see you in the next episode.